Amanda Green, and I'm a science teacher at École Champ-Vallée School in Beaumont.
And I'm Julie Arsenault, and I'm a science teacher at Michael Strambitsky School in Edmonton.
Julie and I met each other about 5 years ago at a science conference, and we try to work together as much as we can on different projects.
We love creating experiences for our students that are unique and allow them to build connections between the classroom and the real world. And this year, this is where we need your help.
Last year, as part of another space-themed grant project, we had our students compare plant growth in earth soil and simulated Martian regolith with a variety of fertilizers. Their engagement in this project prompted us to think bigger. What else would we need to consider to build a colony while protecting our resources here on Earth? This is where our project, Sustainability for Colonizing Mars, was born.
Using tomatosphere seeds, that one was flown in space and one wasn't, they decided to make a Martian garden. And we used different types of soils. One was lunar stimulant soil, one was Earth soil, and one was Mars soil. As you can see, Earth soil worked best, and Mars soil basically didn't grow at all. We found out that you needed at least 25% Earth soil to make plants grow.
We also compared plant growth in sunlight, energy-efficient LED magenta lights, and full-spectrum grow lights. While Amanda's lights produced strong crops, Julie's magenta light plants grew faster and stronger, but then started dying off. We're really curious to study this in some way in the future. Learning to code was important in reaching our goal of designing systems to conserve resources such as water and electricity. Students learned block-based coding with microbits to introduce computational thinking strategies and develop their own plant care systems. Because water on Mars is a rare resource, students were challenged to develop a system that would water plants only when necessary. Amanda's students sifted through mountains of source code to help develop an automated water conservation system where a moisture sensor would turn on a water pump only as needed. Once this has been developed, students from both schools were able to construct working systems, and many quickly realized how much we overwater our plants, crops, and grass here on Earth.
And does it turn off?
Yes, it does!
Students were then challenged to design other sensory and response systems that could conserve resources like electricity. Students created automated lighting, fire suppression, and CO2 alarm systems.
So they're sensing the temperature,
Okay.
like the recommended temperature for plants to be growing.
Okay. And then what's happening?
So if it goes less than 16 degrees Celsius, 18 degrees Celsius, then you'll hear a sad sound. And we just heard a happy sound, so that means it's working.
Yay, it's happy.
High five, guys. Let's go.
Meanwhile, Amanda's students coded simple systems to measure temperature and run lights remotely via Bluetooth, amongst a few other things.
So radio signal to make the light go, and then radio for the temperature.
So now the lights are on, and we have this powered by our solar manager. Okay.
Fossil fuels are not sustainable resources on Earth, let alone on Mars, so we needed to think of some alternatives. Julie's classes experimented with generating enough consistent current and voltage from solar cells to power a microbit, but this proved to be a challenge. Thanks to support from our friends on Twitter, we were able to locate solar managers that could get the job done. This allowed students from both schools to power their systems, at least in part by solar energy. It also gave students an appreciation for how challenging it can be to use solar energy. Another potential source of energy on Mars is biofuel. We used microbits and carbon dioxide sensors to collect emissions data, and students learned that kerosene, a fossil fuel, has more energy available, but it produces more carbon dioxide than ethanol, a type of biofuel. This inspired our next A+ for Energy grant for developing digital environmental monitoring systems. Amanda's grade 7 students will be presenting their findings in a year-end showcase where students will demonstrate how all 5 units of study were driven by a theme of taking care of Earth while being inspired by the journey to Mars. They were fortunate enough to have a variety of guest mentors from inside education and the science community.
Is this 100% Mars soil? Yeah. So I mean, it's dramatic to see the difference here. So it looks to me that as you up the content of Earth soil mixed in with the Mars soil, it looks like the plants are thriving a little bit better.
Julie's students concluded their project with a Mars colonization political platform, a cross-curricular endeavor where students incorporated science into a political platform and subsequent election for their new colony, all the while taking care of what we have here on Earth.
I feel like we use our resources like too much on Earth, that we should like save like our resources, like preserve them.
And what made you think about that?
How like Mars doesn't have much resources.
Okay.
Since Visualizing Independence Party wants to conserve energy and use Mars's resources, we have a Mars water sensor that is here to sense the amount of water our plants are receiving. So if we turn on the switch, this is a water sensor, so this will go in the soil of the plants, and it'll detect when it is sad and does not have enough water, and it will give the plants water until they have the correct amount of moisture. This is very important because we need to save our water.
This part is our solar manager. As the Visualizing Independence Party, we want Mars to become independent and less using of Earth. So instead of bringing battery packs constantly from Earth, we decided to use solar panels.
We thought about how much that wasted energy that we use here on Earth, and that because as we learn and innovatively think about how we can save energy on Mars, we can also think about how we can save energy here on Earth.
This was a massive undertaking, and we are so grateful for the generous funding and to be able to collaborate between our schools. Thank you for letting us be the spark for science in the hearts of our students.